Well, there's a few things about the news that I thought were interesting. Um, America apparently is having less testing than before even, which is interesting and perhaps even means that the current drop in cases is not real. Um, it doesn't seem like we have any realistic plan for ending the lockdown. As everyone has noticed, Trump seems to be very random in his statements and change his mind from day to day. It is actually a very difficult question how you emerge from this lockdown. And I think most Americans are like me. I have no faith whatever in the federal government, but I think our local state government, city government, seem quite smart and they may do a good job of it, as long as we completely ignore the federal government. So I got notice that they're doing more cuts next semester at the college under the new chancellor. So everyone is worried. Several colleges have already started cutting too. They say enrollment is way down. This is interesting. The main reason they say enrollment is down is because people think that the online education is pretty inferior and they're not willing to pay the high prices for these expensive universities and get these poorly planned, clumsy Zoom classes. However, that might, it seems to me, redound to the benefit of City College, where it's free for you to get poorly planned, clumsy Zoom classes like this. And so you might save your money by just taking these. But anyway, we'll see. It appears, I don't think the official schedule for next semester has not come out yet, but it appears that they're planning for yet more cuts. If the enrollment goes up, then maybe they wouldn't have to do that, but nobody knows yet. So I heard this on NPR this morning and I looked it up and I was very disappointed. I've been waiting for a coronavirus antibody test because I thought that I could take that test and prove that I've already had it and then I wouldn't have to worry about any of this stuff. And as more people had taken the test and proven that they hadn't had it, they could all get back to work. And that would be a logical way for us to get out of here sooner than waiting a year and a half for a vaccine. But this had a very damning calculation that sounds very plausible, and I hadn't thought of this. It's just mathematics. So suppose they give you an antibody test, and it has a 5% false error rate. So 5% of the time, it tells you have the antibodies when you don't. Since only maybe 1% of the population is infected, that means it'll tell you 6% of people have antibodies, 1% who really do, and 5 who don't. So most of the answers are wrong. Even if the test is like 98 or 99% accurate, it still means that most of the results are wrong. So any test to be any good would have to have an incredibly small error rate, like much less than 1%. And the current tests, the official government standard is the test should have no more than a 10% error rate. So just the mathematics of the situation suggest that this test will never accomplish what I was hoping it would accomplish, which is that it will tell individual people like me that you're immune and you don't have to worry anymore. In addition, there's a considerable argument that even if you have had this, you're not really immune. That's not so clear. So anyway, apparently the only point of this test is to just get some kind of global statistic about how fast it's spreading and plan large-scale policy. It doesn't help individuals know where they are at all. So it is the only way we can get out of this, I think, is this one here. The only realistic plan to get out of here is, I think, to do what other nations are currently doing. And I think we can pay close attention to places like Singapore and Hong Kong and try to see how well it works for them. But since there isn't any test that's worth anything, we don't have enough tests anyway, but even if we did, they're so inaccurate, they don't really help you much. What you have to do is just have a lot of weak measures, like you take everyone's temperature when they go in places, you make everybody have an app on their phone to see if they've been exposed, you do whatever testing you can, and all these measures are all relatively inaccurate and only sweeping away like half or 2/3 of the people, and you have periods of opening up, and then when you have an outbreak, you have another period of closing down. It's just sort of like when you have a forest fire, and you can't really put it all out, so you drop a lot of dirt and water until it's kind of small, and then you stamp on the parts that flare up because you can't really kill it all. It's that's all anybody can do. And I think we're going to live through a sort of chaotic period. So wouldn't that be mitigated by testing larger numbers? Well, Jimmy, you could test larger numbers of people, and then you could get a more accurate estimate of how many people have the coronavirus. Like if your test has a 5% error rate and the real population has 1%, you could test 1 million people, then you know you're getting 6%, then you know if it went down to like 5.5, so you'd know how prevalent it is. But it wouldn't tell any individual like me whether you're immune or not, which is what I was hoping. And this is, I must say, is what the news stories have been saying for a while, but I did not understand it until I saw this article that explained the math, how it is that the test is helpful for society at large, but it's no use for individuals like me that would like to know we're immune. So anyway, I think this is what we're going to go through. We're just going to have a bunch of incomplete, weak control measures that we have to sort of mix and apply and adjust as necessary. Of course, it reminds me of mosquito abatement and other things like trying to deal with snow on the roads in countries that, in states that get snow. It's a messy process. It's not perfect by any means. You just keep applying controls to try to limit how much harm there is. So that's where you actually need a government that is alert and can change quickly and driven by data and that makes intelligent decisions. And that's why I really think London Breed has done a good job and Gavin Newsom has done a good job. The federal government seems completely out to lunch on conspiracy theories and fake drugs and just lying to everybody to get news headlines and stuff. So I think we just need to completely ignore the federal government. But our state level, I think we can trust our people. And when you do surveys, a lot of people say that. They say our state governors seem to be doing a pretty good job. I think there are some exceptions, but most people, their state governors are doing a pretty good job. If we just ignore the feds completely, we'll be a lot better off. So this company here has testing in San Francisco, supposedly today. In Stonestown, right here in San Francisco, you can go get coronavirus testing. This is Carbon Health, and they're a startup or something. They're not a standard of any part of the government. And so they got the tests. These are the Abbott tests that I think have been talked about by quite a few people. So here they are in San Francisco for a few days, then in Redwood City, then in Pleasanton. They're going all around this area. So you can book and go take a test if you meet certain criteria. And they have an app that you can use to do this, but Google Play took the app out of the store because Google Play has been trying to enforce removal of coronavirus conspiracy theories and misinformation. And so apparently they just implemented some draconian procedure that no coronavirus information of any kind can come from anything except an official government source, as if those were reliable. So any of these guys are arguing with government saying, you know, here we are trying to do something real, and here you are blocking us, expecting us to get a letter from the government. So I don't know what came out of that, but apparently you can go take the test. But as far as I know, you can't get the app to schedule your test. So I don't quite know how you do it, but I guess you can do it through the website or something. So that's some availability for testing if you want to take a test. I'm not quite sure how much good that would do. I think the only point of this is if you actually have symptoms or you've been to the hospital or something. And I think usually the only people I'll give that kind of test to see if you currently are sick with that illness. Anyway, so speaking of hackers, this one's pretty awesome. So if you have a CPAP machine, I've got one. If you snore, you have this machine and it helps you breathe at night. And these guys have now put out the firmware, hacked the firmware and put it in to adjust the pressure to turn this into some kind of ventilator to hopefully help people with breathing problems due to coronavirus. I don't think that's medically approved, but anyway, it's kind of a cute idea. I don't know if this is really going to be a responsible treatment for coronavirus, but I do know that there's a whole community of people that do this for their diabetic insulin pumps, and that turned out to be enormously beneficial. The hacked pumps with modified unauthorized firmware are in fact much better than the official government pumps and official hospital pumps. So this kind of information, it sometimes works very well. And I know the same thing's true of John Deere tractors. John Deere tractors are now very smart. They have computers, they have software. The software has anti-tamper mitigations, and they charge a ton of money for valuable features. So the tractor owners download illegal malware from Russia to hack their tractors to add the features that would be too expensive to get. So there's a whole community of jailbreaking tractors, just like the jailbreak iPhones and now CPAP machines. And it's very interesting hardware hacking stuff. I know Liz is trying to develop a hardware hacking class at City College, which would be awesome, and a car hacking course. She's really big on this stuff. She's done the car hacking CTFs. I'm not very much into this hardware stuff, but it really is an important area of hacking, and we certainly should have it. And Liz is our local expert. But we'll see if the college can get its act together to allow us to add new courses like that. Probably not in any hurry. Anyway, we're here at 128, and let me bring up the schedule. We're nearly at the end. The way these courses are, midterms happen almost at the end. So the midterm grades are up on your Canvas. And I'll put up the way to final grades are calculated within the next week so you can project in the future. There's not much left. We're here on 415, so there's a couple chapters, quizzes on chapter 2, a couple quizzes on chapter 3 that I haven't written yet, a couple lectures I haven't written yet. I've got to do that in the next week or so, and then a final exam. So that's it. You can do all the projects. You can do extra credit projects, of course. If you find projects you can't do for some reason, a lot of people are having trouble with various problems with their emulators or maybe with their real iPhone or stuff. If one project doesn't work, you can do any of the extra credit projects. And by the way, if you want more extra credit, I just did this COBOL CTF. So you can do that if you like. A blast in the past. We did this at GrimCon a couple days ago, and it was a big hit. We got about 40 people, and one guy solved every problem in the CTF, which has never happened before. Anyway, so if you feel like learning COBOL, I'm not sure it's entirely worth your time to learn COBOL. COBOL is a language developed in 1959, but it does run a large portion of mainframes, a large portion of finance, and all the infrastructure, boring things like water purification plants and stuff like that. And there's people are getting so hard to find COBOL programmers, they are beginning to talk about hiring new ones. Anyway, we don't want the iPhones back. Yeah. Oh, I don't know. When you're done with the iPhone, send an email to where the homework goes, and we'll work out how to get it back. I'm not in any hurry. So that's the thing. If you borrowed an iPhone from me, then send an email to the same place your homework goes, and I'll make a list of people that want to give it back, and we'll work out how to get it back. Yeah, maybe you can mail it. Maybe I'll meet people in the parking lot again to get it or something like that. A good question. I'm glad you brought it up. Anyway, I thought I would have to have a big pile of those iPhones to carry to conventions, but it's not so clear if that's going to happen. Although I am going to do the COBOL CTF at DEF CON, I proposed it. So they haven't approved it yet, of course, but I think it'll probably be online. I mean, so far it'll be, theoretically, DEF CON has another 6 weeks before they officially tell us if they're going to happen face-to-face, but I'm expecting it'll probably be virtual. And more I'm hearing that most people expect the college to have only online classes next fall, although that's not officially decided yet. And it will depend, of course, on whether they continue to have to lock down. But I think everything I'm hearing makes me feel like there is no hope of us really having a significant break in this lockdown for about a year. We'll just have a little bit of people going out and working with masks on and a controlled situation, but it won't be back to anything like normal until we have a vaccine. And that will have to be at least a year or year and a half from now. Anyway, so let's take a look at information about the Apple boot chain, which is here. And all right, let's see if I can make this big. There we go. Even bigger if possible. All right. So, all right. So this is information about the Apple security model, which I think you will find is very much like the Android security model, because I suppose Android just copied Apple's general ideas. I'm not really sure that that's what happened, but I imagine that's what happened. So we'll talk about the security model, how the apps are isolated, and how jailbreaking works. And the next time, some more stuff about the security features of Apple. So in the security model, you have the secure boot chain, which is much more than Android has. Android seems to boot up just like an ordinary old BIOS-based computer. There's a bootloader and other things. Apple uses very sophisticated encryption to protect each part of the boot chain. That's why jailbreaks are so hard to make, and it was such a massive accomplishment when Axiom X made the checkrein exploit. So the code is signed, the processes are sandboxed to prevent one app from touching the data from another app, and the data at rest is encrypted. So if somebody steals your phone, they can't get in. And there are the usual security features that you'll find in any other modern operating system: address space layout randomization, non-executable memory, and stack smashing protection, which we talk about greatly in the exploit development class, because we spend quite a bit of time developing ways to get past these mitigations. So when iOS starts, it starts with a boot ROM and then goes to something called LLB, then an iBoot, and then the kernel, and each step is cryptographically signed and verified. So it starts with the boot ROM in the read-only part of the processor, and this contains the public key, which is used to verify the next step. And this is, I think, the heart of the checkrein jailbreak that we've been using in the project. It's an error in the boot ROM, and that's why the developer said the great thing about this one from a hacker's point of view is Apple cannot fix it. There's a whole, all the iPhones from the first 64-bit one, which was 5S or 6S, right to the one, I think the 10 or the 9, all those ones have a defect in the ROM and you can't fix it without buying a new phone. So Apple can't put out a patch, and therefore all those phones will remain jailbreakable until the hardware is changed, which is pretty nice. That's why, I guess if you're Apple, you really have to try hard not to be making mistakes in the boot ROM, since you can't fix it with an update. Anyway, so the boot ROM is used to start the machine, the phone, and then verify the next step, the LLB, the low-level bootloader, finds this iBoot, which is the next step of bootloader, and verifies that it is intact. If that fails, it boots back into some recovery mode, because although you can't fix the boot ROM, from this point up, it is all software or firmware, and I think you could, in principle, restore your phone to like factory defaults or something and get it working again. So it can fail from here back to recovery mode. If the boot ROM fails, I think you're toast. Your phone is just broken, the hardware is broken, and there's no software way to fix it. Then iBoot is what loads up the kernel. The kernel, of course, is the part of the operating system that is always in RAM, and it runs at full privileges. And in every modern OS, the kernel is the only part running with full privileges, and all the apps are running in user land with lowered privileges, and they interact with hardware through calling API calls into the kernel. So this is going to start iBoot, which then is the kernel, which will now load the user mode environment in the OS and let you log in and launch apps and such. So every iPhone and iPad, all the versions for a long time, have had a hardware coprocessor, which Microsoft calls a trusted platform module, or Intel calls it that. And this is what serves the purpose of making it a cryptographically secure environment, which meets the Navy's military specifications for a trusted computing environment, they call it. And they call it a secure enclave. And Apple uses it for crucial cryptographic data. The point of this is the cryptographic information is stored on a special chip which has its own processor and is not accessible to the main processor at all. So the main processor could not access the keys. All it can do is send a request to the cryptographic chip, please use your key, which I can't see, and decrypt this stuff. So that's the point. And this is used for the fingerprint data and data protection. And on Apple phones, it's used for Apple Pay. That's part of why I was motivated to get a new phone a few years back, because I wanted to use Apple Pay. You have to get a relatively modern 64-bit phone with a secure enclave, and then it's much more secure than using a normal plastic credit card. It's better. Your essential data is stored in that secure chip, and it's really quite good. All right, so the secure enclave is part of the ARM trust zone, and the point of this is the data in here is safe even if the kernel is compromised. Even if you jailbreak it, it's no software running on the phone from the apps in the kernel anywhere can steal the secrets hidden in there. The only way I've ever heard of anybody stealing secrets from this one is on a desktop computer or a laptop with a trusted platform module. Some people dissolved it. I think the Noisebridge people were part of the team. They dissolved the trusted platform module with acid and reached in with a microscopic needle to find a pin and suck the key off that way. So it's pretty heroic to steal the data off of this, and it's not an easy job at all. So there's something called Cachegrab. This is a kernel code that can steal something because of shared cache memory. This reminds me of Spectre and Meltdown, which has rocked the security world for the last couple of years. There are some shared memory components between some of these secure enclave type structures and others, and sometimes it's possible to get some information about what's in there. So apparently there's a similar weakness here that does make some leakage of data out, but I haven't heard of it turning into a really serious problem. All right, then you have your apps are code signed. We talked about this in Android. As we saw, apps are signed, but the signatures are self-signed, so you can make a fake app with a fake self-signed signature, and it's not easy to tell from the real one. So you can put up a fake app in a fake store and people can install it, but you can't be doing that with Apple because it has to be signed by Apple. It has to be a trusted signature and in a provisioning profile signed by Apple. So you can only submit them to the App Store. There is a thing called sideloading where you approve a private non-store app, and that is considered a security loophole in Apple phones. So if you could trick people into putting on a company profile that allows sideloading, then you could in principle put an app that didn't come from the store. But that's basically a social engineering attack. Most people download everything from the store, and therefore everything is signed by Apple. And Apple cleans the store very thoroughly. They have both automated tests and manual tests to see what's in the store to try to keep all the malware out of the store. And they're really very effective. There's very little malware in the Apple store. There have been a few cases, and people are punished and thrown out. There's just a ton of malware in the Android store. Their store security is much better in practice. And once you install the apps, each app is isolated from the other apps, just like it was on Android. In fact, even to a greater extent, it's got a sandbox kernel extension to separate each app from each other and from the OS. It's got its own unique directory. And so the Apple Sandbox has gone through various versions. Now, I think the very first iPhone, everything just ran as root, but then they introduced a thing called Seatbelt, which was a simple way to isolate apps from each other. Then they revamped and called it the App Sandbox. So it now has something like containers. And in the later version, in iOS, well, these are Mac OS. So in iOS, it became much more strict. And there's a whole thing, I've linked in my links, chapter 2b, you can find a whole slide deck from the security conference going into great detail about the Apple Sandbox. As you should expect, they really have gone to great effort. Apple is really, really concerned with privacy and security. Like I say, they're in trouble with the FBI because they've encrypted stuff so much the FBI can't get in. It's really a big thing for Apple, which I must say, there's advantages to that. Like right now, when Apple and Google just last week announced that they're developing a special API to track whether you've been exposed to coronavirus, and they're hoping that everybody will trust them so much that they will install this app on their phone and then use it to find out if they've been exposed to coronavirus, even when they probably really don't want that data going to the government, being used to put you in a concentration camp or something. I think Apple is far more trusted than the federal government. And this is where their extreme attention to privacy probably is going to pay off. I think they're one of the most trusted brands in America. And even the most cynical, people that I know say, I probably would trust Apple with that data far more than I would trust Facebook or Google or the US government. So anyway, it may turn out to have some benefits. In addition to, of course, the cost, which the FBI is complaining about, that if a bad guy is doing some kind of horrible crime and they're using an iPhone, the government can't get the data even for evidence in court, which is a cost socially. Anyway, so just like Android, your app needs permissions to access things like the microphone and the media and such. All your data is encrypted before you ever use the phone at all. When you first bring it up, everything is always encrypted with a key generated on the first boot. And so it's all encrypted with AES. And that's why when you remote wipe it, all it does is erase the key and that data is all gone forever. Without the key, nobody can ever get in. And that turns out to be extremely effective in practice. So you can easily wipe your phone and resell it, like all these used phones I've been buying that you guys are getting. They were all somebody's phone and they just reset it to factory defaults. And that really means all the data is gone and you can safely resell the hardware, which is not true of laptop computers or Android phones or anything. There's not an easy way to wipe them to make it safe to sell them. It's one of the many problems with them. Anyway, so that's the data protection API. And there are different layers of the encryption. So there's some stuff that's encrypted but available as soon as you boot up, and there's stuff that's only that's got another layer of encryption that only decrypts when you log in. And that's why if you do the jailbreak we've been doing on a phone that is somebody else's phone and you don't have their PIN, then you can get in the OS and see the system files, but you still can't see their emails and pictures and stuff. That's behind the other layer of security. So it really is very strong and very complicated. There are multiple cryptographic layers of protection. Then there's protection against exploits. You might imagine people will find vulnerabilities like the jailbreak and like malicious apps and such. So they have the general mitigations that you'd see in any other OS. For example, write or execute. This has been the way Windows has worked for years, and iOS does it also. When you run an app, it has to have some memory. And each memory region it allocates can be either writable or executable, but not both at the same time. This is the same thing that Microsoft calls data execution prevention. And it's using ARM's execute never, XN feature. So this is good. And by the way, I don't believe this is true of Windows. I think we have some attacks in the exploit development class where we take a region that was writable, but not executable, and write to it, and then we're able to change it to be executable. And later in class, when we do the Raspberry Pi, we're going to see in the Raspberry Pi on ARM, every memory region is in fact read, write, execute permissions, which violates this rule, but not on the iPhone. On the iPhone, you can't have an area where you write to it and later on make it executable in the same app, or so they say. There may be some way around this, but this is a very good idea. That would mean you probably have no way to inject code and run that code. Doesn't mean it's impossible to exploit the phone, but it's much more difficult. The way you exploit the phone, of course, in this case, when you cannot inject any code and execute it, what you do instead is inject data and use the data to take over the phone. You inject a bunch of addresses, and then the addresses are used to control execution, and the addresses point to code that the developer put there. So you take the blocks of code that were written by Apple or usually the OS maker, and you paste them together, like taking letters out of a newspaper and building a ransom note. That's called return-oriented programming, where you take a few instructions here and then a return, a few instructions here and then a return, and you paste them together to make your exploit. We do that in 127 for Windows and Linux. And that's that same technique you have to use for the iPhone. This is how you get around non-executable defenses. If you can't execute any code, you have to reuse code that was already there for another purpose, because you can't inject any new code. Now, another defense is address space layout randomization. In the old days, you would compile code, it would load at a particular place in memory and would always be expected to be at the same place in memory. But now you can compile it as position-independent code, so it can be relocated to anywhere in memory, and the operating system will randomly relocate it whenever it launches. And this means when you try to make your ROP chain to do return-oriented programming, you're trying to find instructions that the developer put there to reuse them, but they're all randomly shuffling every time the phone reboots. So you can't find them easily. It makes it much more difficult to exploit the phone. That's the point of this. Now, in Windows, the way you do it is you just find modules where ASLR is turned off, because unfortunately, it's not turned on for every piece of software in there. So that's kind of rude. And I would imagine it's probably the same for the iPhone, but I haven't got to that level of detail. So here's some weaknesses. In the old versions of iOS, there was a module that was not relocated. Another way you do it is you find memory disclosure bugs. There are often bugs where some kind of data is written somewhere where you can find it that gives you an address that you can use to find the code. So that's the game. All right. And so some apps also put data at a particular location at a fixed address. So ASLR would be great if everything used it 100% of the time, but like any other security defense, you can lock the doors, but somebody forgot to lock a window somewhere. There's often another spot. And that's all any defense ever does, is make it harder for the attacker. There's nothing ever perfect. And then stack smashing. This is a defense that's been around for a long time. If you want to do a classic buffer overflow where you have a string variable and you put in extra characters bigger than the string should be that leak out of the string and hit a return pointer, so you gain control of execution, then the defense against that is stack canaries, which puts a random value at the end of each stack frame between the data and the stored return pointer. So if you overwrite that, it detects it and won't return. And so that's a defense in almost every modern operating system, and Apple has it too. So then there's the apps. There are standard native apps and browser-based apps and hybrid apps. So this is the most common type of app on iPhone. Now, remember in Android that most of the apps are written in Java and compiled to Smalley and running in a Java virtual machine, which made it very, very easy to read the code and modify it. In Apple, however, it's more like a Windows PC, or for that matter, a Linux PC. Your apps are written in C, Objective-C or Swift, and they're compiled out of native code. They run in assembler. And so now you have the obscuration that it's very hard to reverse engineer it. You don't have readable variable names and stuff. So it's much more like Windows or Linux desktop machines in that regard. And so now it's just going to call the SDK and so on. Apple Software Development Kit is what it's going to use to control the phone. So that's the native apps, and that's the way most apps are. Then there are browser-based apps, which are basically web apps that just run on the phone in a browser. So you open them in mobile Safari, and therefore it's very much like developing web apps. And there's hybrid apps that make their own native wrapper to display it. Like we talked about in Android, they would use their own local browser inside the app. One thing that makes people very fond of browser-based apps is you could in principle make them device independent, where the same app or a very small variation would run on different devices, because it's really just a web app, but you're really just using a browser. All right, so the way these are distributed, like we talked about, the normal way you do it is with the App Store. You have to have a real Apple developer account. You have to pay money to Apple. Apple has to know who you are. And so that's, whoa, what's this? I guess somebody's figured out how to use the whiteboard or something, unless I'm doing it by accident. Anyway, all right. See, I got any chat? Okay, okay. All right, anyway. All right. So that's the App Store. All right. You can also distribute apps with enterprise distribution. And this is where you have custom apps and you sign them with an enterprise developer certificate. You can run them on various devices. You can also distribute a few, up to 100 for testing. I'd like to get some of this going. It's one of the things I'd like to have in this course. We should make our own little app that we can distribute locally. I haven't gotten that far, but that's side loading. I see somebody's figured out how to turn it off. Yes, there is a whiteboard. My sister uses it. Somebody figured out how to do it. And I guess I'm not in control of it. So that means somebody could be Zoom bombing by using a whiteboard. So anyway, I should, if it turns out to be a problem, I'll figure out how to turn it off. But anyway, all right. So, all right. So you can, there is a way to distribute apps to a small group of testers or even to a lot of people in a company with these enterprise certificates. And I haven't done that, but if any student has experience with that or knows about it, let me know. It might be an interesting project. And then, of course, there's, you can abuse certificates sometimes. This is what the Pangu jailbreak did. It changed the system date back to the past and then used an expired certificate, which is a pretty simple trick, but it's one way to put software on there that's not approved by Apple. And of course, that's what all jailbreaks are. All jailbreaks are finding some way to put on software that is not approved by Apple, so you can do the things that Apple doesn't want you to do. So the app structure sounds very much like an Android app. You have an IPA archive, and that's just a zip load, including everything. Payload, the application itself, the artwork, the metadata like the developer's name, just like Android has the manifest file and all the signatures and everything here. So in the old days, every app had access to everything on the phone, but of course, just like Android now, they have a whole series of data classes now. Your contacts, your photos, your microphone, the motion activity, and all that is available. And so when you install an app, just like Android, it says this app wants to access your contacts. Is that okay or not? And you get to control this. And if you go in the control panel, you can turn it on and off. Who's able to get to your contacts? I want this app to get there, but I want this app to no longer get to my contacts, and so on, which is, you know, that's good. That's the granular control. All right. iOS 8 has more choices for location information. I see this all the time on my phone. I install some app and it says this app would like to know about your location. Do you want it to always have your location or just when you're using it? About a month or two ago in the news, I saw this article that Waffle House, I think it was Waffle House, some restaurant was not open on Sunday, and they decided to find out where everyone goes to eat on Sunday when they can't go to that restaurant. And they just tracked everybody who had the app on their phone when they weren't using the app on Sunday, and just published the results casually, apparently in the belief that everybody understood that just installing that app means that they're keeping track of everything you do all the time, which I think people did not know. And that's the issue here. I would think the most logical thing to do would just be this. If I approve some app to use my data, I would think only when I'm using that app, not just all the bloody time. But anyway, apparently the Waffle House app or whatever restaurant it was doing that, and people didn't know it. So then there's jailbreaking, of course. So the reason you jailbreak is now you can get the Cydia store, and you can just download a whole bunch of pirate apps that are stolen apps, so you can get them without paying for them, and apps that do hacking things and turn on features Apple doesn't like. You know, it's like now you have total control of your hardware, and you can do whatever you like. So of course, you've weakened the security. The entire point of jailbreaking is now you are outside Apple's security model. You can run code that has not been approved by Apple, and therefore that code could be malicious. And there's quite a bit of iOS malware that runs on these jailbroken phones, because the other thing is most people when they first jailbreak their phone, they don't realize that when they turn on SSH, it's got a default password and it's the same on every phone. So they often expose their phone to a trivial attack like other IoT devices when they first jailbreak. So iKey was the first one, and then there was another iKey coming after that. And there was a malware campaign called Unflod Baby Panda that tried to steal Apple IDs and passwords with some kind of keylogger type software. And so anyway, that's the problem. Once you jailbreak it, you have to secure it. If you don't jailbreak it, you're trusting Apple to secure it. And that, in fact, is very good. If you just play by the rules in Apple's little walled garden, you're really very safe. But if you leave, then you better consider your own security model. So an untethered jailbreak means you can connect it to a computer, install the jailbreak, and then disconnect your phone and turn it off and reboot it. It will stay jailbroken. That's what most people really want. They want to jailbreak it once and then continue to use it jailbroken forever. The tethered one means that you have to, every time you restart the phone, you have to reconnect to the machine. And the jailbreak we're using is a tethered jailbreak, the check-rain jailbreak. So if you disconnect from the computer and turn the phone off and turn it on again, it's no longer jailbroken. That doesn't mean all the files that you put on it are gone, but it means it's now the official Apple iOS that will only run official file programs. And there are various other ones in between. Yeah, semi-tethered. Oh, I see. I guess this one's semi-tethered. Okay, because what happens with the check-rain jailbreak is it's jailbroken while you use it connected to the original computer, but if you reboot, it comes up in a non-jailbroken state. It's not just, I guess it's not a tethered jailbreak in this regard. You don't have to go to recovery mode. You just end up in a non-jailbroken state. So it's technically semi-tethered. All right, so Jailbreakme is a very common website. I mean, they make jailbreaks. They put them on jailbreakme.com every few years, and then it's easy to jailbreak your phone for a few weeks. You can just go to this website. It hasn't been possible for years. There hasn't been a jailbreak that handy, as Apple's fixed those. But anyway, here's one that would just let you see a PDF file you could take over the machine using a return-oriented programming payload. And then there was an evasion jailbreak that used bypasses to get in through the lockdown D service. And there's just a series of these jailbreaks coming out. And like we say, the cool one now is Checkra. So after you jailbreak the phone, then you install OpenSSH, which comes in with the check-rain automatically, and then you can connect with Wi-Fi or USB, and the default credentials are mobile and root for the username, and the passwords are all Alpine. So Cydia lets you have the pirate app store where you can put on anything you want. Big Boss is the Unix tools that give you command line tools like apt and so on to do all the usual command line Unix things. CC tools give you more information to parse and assemble and link Mako binaries. That's what these things are called. If you have a Windows machine, they're called portable executable files. If you have a Linux machine, they're called ELF, executable link format. And on iPhones, they're called Mako binaries. That's the structure of the binary file. And so if you want to look at the internals of Mako binaries, you need these tools. OTool is the tool that shows you the class and method names and the libraries and symbols inside there. And NM shows the symbol table, and Lippo, iPhone apps, and for that matter, I think Android apps can be fat apps, which means there's actually several different copies of the app compiled for different environments in the same container. And Lippo is what you do to manage that. And the point is Lippo can take a fat app and make it into a thin app. It can reveal the multiple copies of the app for different processors that are in there and extract them. Any luck finding credentials with CC tool before? No, I haven't done that yet. Yeah, I've been distracted by other things. Yeah, it's a very good question. I wonder if you're going to find API keys in Apple apps, and I think you will. I think I made some distance doing that before I got distracted by other things. And so GDB, you have a GDB that runs as a debugger. On iOS, people say Radare has a better version of it. There's another one I've been using in some of the projects I haven't finished yet. I've been pretty far down some debugging project with iOS before I get distracted by other things. I may get back to it, but for a while I've been distracted by things like COBOL. Anyway, CodeSign is Apple's signing tool, and LDID is another code signer, ways to sign and display signatures on apps. And here's the tool you need to install unsigned apps. remember, the way we did it before, Android won't install online signed apps unless I think you make an adjustment to allow that. And here's the hacking tool that will let you install unsigned apps, of course, only on jailbroken devices. Non-jailbroken devices will only install signed apps, and normally only from the Apple Store. All right, so if you have a jailbroken device, you can, and you have the PIN to log in if there is one, then you can access every file on the device. You get the full access to the file system. If your device is not jailbroken, then you have very limited access to the file system. That's the whole point of the Apple structure. Your app can store pictures and things locally, but it can only access certain areas. And the reason is then you can explore the data that came from your app and you can back it up, but you can't really mess with the operating system or even see the operating system because Apple doesn't want you to, which is why the jailbreak community is so important for iPhone security, because if you can't, after you jailbreak a phone, then people can look at the Apple code and find holes in it, and it sort of makes their operating system an open operating system more than they want it to be. So anyway, on a jailbroken device, you can see the applications here, the third-party applications, voicemails, SMS, photos, videos, and the contacts database. You know, if there's a standard layout of where things are, and you can get them here. And this is also useful if you want to copy them all to get forensic data off an iPhone. Their plist files are these binary format files that store serialized objects, and we were playing with them before. In the iPhone projects. PLUtil lets you read what's inside there. And then you've got binary cookies, which you can open with this Python script, and SQLite databases. So, you know, it really is very much like Android, which is not a mistake, I think. Anyway, let me bring up the Cahoots, which are here. And this is 128.2a. So that should do it. And let's do this, and that, and that. All right. And I should have someplace, here's a place to put scores. Okay, good. And it looks like I got enough people. Good. All right. Yeah. If you want to schedule office hours, just let me know. Right after the lecture, we can talk, or we can schedule any other time. All right, I'll give it another few seconds. I think 7 might be all we're getting. All right, apparently this is it. All right, which one falls back into recovery mode if the signature fails? Yeah, that's LLB. The boot ROM can't do it because it can't run it all without that. And iBoot is later when it's going to give you a login menu and such. The LLB is the part where it falls back to recovery mode. All right. All right, what's the default password? Okay, Alpine, good. All right. And what mitigation do you bypass with ROP? Okay, bypasses non-executable memory. The point of return-oriented programming is you reuse code that the developer put there. So that code is already executable. And the stuff you're putting in is data, not code. That's the point of return-oriented programming. All right. And what feature was introduced as a seatbelt? Okay, that's sandboxing to protect the data in one app from the other apps. All right. And what was the first worm? iKey, that was it. I think it just rickrolled you. Anyway. All right. And what mitigation uses XN? Okay, that's non-executable memory. ARM calls it XN. Intel calls it NX. Anyway. All right, so Rich, Ken, and Peter. All right, you folks are the winners. All right, I'm going to stop recording, but I will leave